Okay, let's do page 2. Graph the equation. If necessary, write the equation in slope-intercept form first. Slope-intercept form means that we're going to need to have it in y is equal to mx plus b form, where y is isolated on one side of the equal sign. Already done here, not possible here, and remember f of x is the same as y. So let's talk about these first three equations. For this one, my slope is equal to 1 and my intercept is equal to 0. I start at my intercept and I count a rise and a run of 1 to 1. All I need to do now is get my straight edge and connect my integer coordinates. Remember, arrows as endpoints and a nice bold line across the entire coordinate plane. This one I was curious about because it is a vux. I know it's a vux because it has only an x in the equation, which means it's a vertical line with an undefined slope. So I look to my x and I see negative 1, 2, 3, which means every single x is only equal to negative 3, which is going to create a vertical line at negative 3. Arrows as endpoints, and I'm set. For this one, my slope is going to be 3. I have no y-intercept, which means that this point goes through the origin. When I look here, I have a slope of 3, so I'm going to rise 1, 2, 3 for every 1 that I run. Rise 1, 2, 3 for every 1 that I run. I could also fall 1, 2, 3 for every 1 that I go back. Fall 1, 2, 3 for every 1 that I go backwards. So whether my slope is equal to a rise of 3 and a run of 1 in a positive direction, or a fall of 3 and a run backwards, notice it's always linear. All of my solutions line up in a straight line. Arrows as endpoints. Alright, moving up to the middle row. When I'm looking to solve here, I need to solve for y. It needs to be in function form. So I need to go ahead and add 1 to each side, giving me y is equal to x plus 1. A y-intercept of 1 starts there, and I need to rise and run at a slope of 1 to 1. Rise 1, run 1, rise 1, run 1. Fall 1, back 1, fall 1, back 1. And I can go ahead and grab my straight edge. Connect. My y is solved for, so I'm in good shape. Again, I have an intercept of 0, which means I start at the origin. My slope is negative 2/3. Keep in mind whether that negative goes with the 2 or whether that negative goes with my denominator. It's the same thing. So if I fall 1, 2 and run positive 1, 2, 3, a fall of 2 and a run of 3, or if I rise 1, 2 and I run negative 1, 2, 3, rise 2, backwards 3, I still end up with coordinates in a straight line. Remember, the solutions of every linear equation always line up in a straight line. I connect my integer solutions and add arrows as endpoints. F of x is the same as y, and it's better to write your slope and your x term first, this variable term first, so I can use a commutative property and just switch them around, making sure I keep this sign with my value. Y-intercept of positive 3, that's where I'm going to start my graph. And my slope of negative 2. So my slope is equal to negative 2 over 1, or I can have positive 2 over negative 1. Either way, it's going to be a line that's decreasing from left to right. Down 2 over 1, down 2 over 1, down 2 over 1. I could rise 2, run negative 1, rise positive 2, run negative 1. Notice all of my dots line up in the same place, and I'm set. These next ones are a little trickier because I'm going to need to solve for y first. Need to solve for y, need to solve for y. I'll add 4x to each side. Negative 3y is equal to positive 4x plus 9. Divide by negative 3, divide by negative 3, divide by negative 3. Positive y is equal to negative 4/3 x minus 3. We'll start here at my y-intercept. 1, 2, 3. And I need to count a fall of 4. 1, 2, 3, 4 for every positive movement of 3. 1, 2, 3. I could also think of this slope-wise, a fall of 4 and a run of 3, or a rise of 4 and a run of negative 3. 1, 2, 3, 4. 1, 2, 3. Notice I end up with my points in a straight line that I can connect, add arrows as endpoints. When I solve for y, I'm going to add x to each side. 2y is equal to x plus 20. Divide by 2, divide by 2, divide by 2. Positive y is equal to 1/2 x plus 10. Here's my y-intercept. This is going to be my b. So I'll go ahead and start at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My slope is equal to 1/2, but I'm out of room on my grid. I can't move up. So if I notice a fall of 1 and a run of negative 2 will allow me to stay on the graph. So a fall of 1 and a run of negative 2, a fall of 1 and a run of negative 2, a fall of 1 and a run of negative 2 allows me see, fall of 1, run 2, fall of 1, run 2. This one's a little off. There you go. It allows me to use my straight edge and see that this line can be graphed that way. Alright, when I go to solve for y, the x term needs to be on the opposite side of the equal sign. 2y is equal to, we're going to go ahead and put x first. Divide by 2, divide by 2, divide by 2. Y is equal to positive 4x minus 3. Here's my y-intercept. Down 1, 2, 3. And I'm going to count a slope of 4. Rise. 1, 2, 3, 4. Run 1. Rise. 1, 2, 3, 4, run 1, rise, 1, 2, 3, 4, run 1. Grab my straight edge, connect my dots, and I'm set.